All right, so we are talking about the end behavior of the graph. So still looking at if it's acting even or it's acting odd, but it's not going to be entirely an even function or entirely an odd function because we don't really care what's happening in the middle of it. We're just looking if the ends are both going up like an even function does or the ends are going in opposite directions like an odd function. So the way we determine the end behavior is we look at the degree, which if you remember, the degree is the highest exponent, the biggest exponent in the equation. So for example, if we had y equals 5x squared plus 3x minus 1, the degree is the biggest exponent, so the degree there would be 2. Because we're just looking for the biggest exponent. The leading coefficient is the coefficient in the term with the degree. So it's not necessarily the first or the biggest coefficient, it's the coefficient that matches with the term that has the biggest exponent. So leading coefficient and remember coefficient is the number in front of the x, coefficient with the degree. So I could say, for example, y equals 4x cubed minus 7x. My leading coefficient there is going to be 4 because my degree is 3. So once I decide that my biggest exponent is 3, then I look at the entire term and I say, okay, my coefficient in that term is 4, so my leading coefficient here is 4. So degree, biggest exponent, leading coefficient is the number in that term in front of the variable. So in order to decide the end behavior, we have 4 possible options because we can have an even function or we can have an odd function. And then we can have a function that's acting even and positive or even and negative. And then we can have odd and positive or odd and negative. So if we're looking at a function that has an even degree, 2, 4, 6, even number degrees, and it has a positive leading coefficient, that means both ends of the graph will go up. So even and positive makes you like that smiley face. It points up. Both ends will go up. So your graph, if you were going to draw yourself an example, an even degreed function with a positive leading coefficient, the ends of the graph will always point up. And we don't really care what's happening in the middle. It might be a pretty smooth parabola. It could be a quadratic function. It could be anything. Something crazy could be happening in here. It could look like this. We don't really care. We just care that if it's even and it's positive, it's acting like an even function, so both ends are going up. An example could be something like y equals 3x squared minus 1, because my degree is even and my leading coefficient is positive. So here, my degree is even and my leading coefficient is positive. So if I still have an even degree, but now my leading coefficient becomes a negative number, all that's going to happen is both ends of the graph will face down. And you saw this with parabolas and when we talked about reflections. So if we throw a negative in there, all that's going to happen is the graph is going to flip upside down and both ends will face down. So that's something where both ends of our graph are going to go down. And it could be something simple as an upside down parabola. Could be something that looks like this. So it's not going to be an entirely even function. It's not going to be completely symmetric over the y-axis. It might be, but it doesn't have to be. We're just looking at if the degree is even and the positive or negative leading coefficients to decide what the ends of the graph are doing. So we're only concerned with what's happening here, what's happening here, here, and here. An example of this could be like negative 2x to the fourth minus x, where my degree is 4, and my leading coefficient now is negative. My degree is even, my leading coefficient is negative. So your homework is going to ask you sometimes to look at the graph and decide if it's even or odd, and if it's a positive or a negative. And sometimes it's going to ask you to look at the equation and decide if it's even or odd or positive or negative. So sometimes you'll pick out like, oh, both ends of the graph are going up, so it's even, and it's positive. Or both ends of the graph are going down, so it's even and it's negative. Or you might look at the equation and say, oh, the degree is 2, and that's even. And the leading coefficient is 3, and that's positive, so it's even and positive. Weird? Okay, let's look at the odd ones, and then we'll do some examples to clear it up. So, if we have an odd degree, we can still have a positive leading coefficient or a negative leading coefficient. Our odd functions are going to go in opposite directions. So odd and opposite. So if I have an odd function with a positive leading coefficient, it's going to look like it's kind of traveling up as I travel along it. So this is going to start pointing down and end pointing up. So if we were looking at a picture of that, the left side is pointing down, the right side is pointing up, and something is happening in between. It could be something simple like a cubic function. It could just be a straight line. It could be crazy. We don't care what's happening in the middle. We just care that the left side is pointing down and the right side is pointing up. An example of that, if we were looking at an equation, could be something like y equals 5x to the third minus 2x squared, where my degree is odd and my leading coefficient is positive. So it's just giving us more of an idea of what the graph looks like without having to actually graph it. Go ahead.
Does the line have to hit the origin?
Nope, doesn't matter. So it could go through the origin. We could end up having a graph that goes like this. It doesn't have to act like an odd function anymore. So like our odd functions had to go through the origin because they had to be symmetric over the origin. This is just acting like an odd function, even though it's not completely odd. So it's just kind of giving us a general idea of the shape of the graph before we actually go in and try to graph it. So then, if it's odd and negative, instead of starting low and ending high, it's going to start high and end low. So it will start up and end down. Which means it looks something where it's starting on the left pointing up, it's ending on the right pointing down, and something is happening in between. It could even be as simple as back in the day when you had linear functions that were straight lines. Linear function would be an odd function because one end is up and one end is down. So it could be a complicated graph like you're used to seeing now, or it could be very straightforward. We don't really care. We just care what the ends are doing and what's happening on either side of the graph. So we can have an example here. Y equals negative x. My degree here is 1 because it's not written. 1 is an odd number. My leading coefficient is negative 1, which is negative, so it's pointing down. Another way to help you remember it, if you think of even, if things are even, they're kind of fair, right? And when they're fair, it makes you happy. So you get a happy face if it's even and it's positive. But if you're sad and it's negative, if it's not fair because it's negative, then you have a sad face that's pointing down. Very sad. Odd always goes in opposite directions. If it's positive, it looks like it's going uphill. If it's negative, it looks like it's going downhill. So, your questions today are going to look like this. Determine the end behavior of the function below. So your options are even or odd, and positive or negative. So determine the end behavior of the function below. A says y equals 3x squared minus 1. So you want to pick out the degree and the leading coefficient. Degree tells you even, odd. Leading coefficient tells you positive, negative. So if you look at A, you've got y equals 3x squared minus 1. What's your degree?
Even degree.
Your degree is 2, right, which is even. Your leading coefficient is what? 3. Is 3 positive or negative? These are tricky questions, aren't they? Positive. So we would say the end behavior is even and positive, which tells me before I even pull out my calculator, or if I happen to forget what a quadratic function looks like that's moved down 1 and stretched by 3, if I forgot that, I know that this is an even function and it's acting positive, so both ends of the graph are going up. Do you possibly see where this is headed?
Oh, wait.
What about... Oh, man. All right, look at B. What's my degree for B? If I've got y equals negative 2x cubed plus 4x to the 5th. What's my degree?
5.
Degree is 5, so my degree is odd. My leading coefficient is 4, which is, well, yes, but I don't care. I just care positive, negative. Positive. So I've got an odd and positive end behavior. So odd and positive. So without even graphing it, now I know it's odd and it's positive. Yes? Cool. Cool. What about this third one? C. We have to distribute. So just like with symmetry where we couldn't decide, or with even or odd we couldn't decide, so we've got to distribute that bad boy first. But thank goodness we've dusted off our distributing skills from last time, right? And we know when we distribute those bad boys, what with their exponents? Yeah, add. We add them. So when I distribute this, I end up with y equals 3x cubed, because 2 plus 1 is 3, minus 4x to the 4th, because 2 plus 2 is 4. And then I have to look, okay, what's my degree? 4, which is even, right? My leading coefficient, positive or negative? Negative. So it's even and negative. So in general, it looks like this. So if I give you an equation, you're just picking out the degree, picking out the leading coefficient. Or I can give you a graph and ask you to find the end behavior of the graph. So now you just have to remember what we talked about, the shapes, and say, okay, are the ends going in the same direction or opposite directions? Is it happy or is it sad? Is it going uphill or downhill? So if you look at the first one, they're both going down. Even and negative. Even and negative. B. Odd and positive, right? Because if this was a roller coaster, if I jumped on here and I started going along, I'm moving up. So this is odd and positive. What about C? Odd and negative. Yep, because I'm starting high. It's going in the opposite direction, right? It's going down. Odd and negative. All right, do you think you need to stretch before we play the game? Maybe. All right.